today we're here to talk about integrating with Google Apps and some of our new APIs and features and thoughts as we design our APIs. Again, my name is Ryan Boyd. There's my Google profile as well as my Twitter handle. If you have any questions, please save them for the Q&A at the end of this talk. And if we don't get a chance to answer them during the Q&A, feel free to reach out to me on the social networks there. All right, so what we're talking about. I'm going to give a quick overview of Google Apps and our API platform that we provide, then talk in a little more detail about the Google Data Protocol and the future as we iterate on that with our Google Apps APIs, and then go into some of our recently launched APIs. And these are recently launched APIs in the application API space, as well as the administrative APIs, as well as Google Apps Script. And then go into some quick distribution opportunities. But the meat of the presentation will be really spent on how we're iterating on the protocol of our data APIs. So Google Apps. How many of you actually use Google Apps day to day? All right, nearly everyone. Good. This is something I like to see. 4 million businesses use Google Apps, 5,000 new businesses a day, 40 million active users. It is basically a communication and collaboration suite. That's how we look at it: email, calendar, docs, et cetera. So from a platform perspective, though, or from an API's perspective, we look at it in these three pillars. So we look at Google Apps as one essential thing that our customers need in order to run their businesses on the web. We believe in this vision of 100% web, where every customer is using the web entirely for their business. They're not installing desktop apps. They're not installing server apps. They're using the web. But in addition to the Google Apps Suite, our customers need other types of applications. And these are types of applications that you guys build. So there are the applications in the center there, which are the custom applications. If a customer comes to you and says, hey, they want to integrate with their HR system or their finance system, something proprietary, we believe you should be able to do that with our APIs. And we also provide hosting platforms like App Engine and other things, like GWT and all, to make it easier for you. And then this third category is if you want to kind of leverage and scale the work that you're doing providing these integrations, you can build custom applications. Sorry, you can build applications for sale to customers. And these are applications that basically integrate with the data APIs to connect users with their data to basically make the users more efficient in their day-to-day life of running their business on the web. But all of this sits on top of this cloud management platform, which is things like users and groups and authentication and authorization. And then we also have other things that sit on top of that, which is like Chrome and Chrome OS and Android to give you a modern 100% web experience for businesses. So data APIs that we have, all the different Google Apps products, basically. And then we have the administrative APIs, some hosting with App Engine and Google Apps Script, and then some UI extensions via gadgets. But we're going to spend a lot of the time here is on the data API side and what we're doing to build the next generation version of these data APIs, how we're iterating on our existing Google Apps APIs to build something better for you guys based off the experiences we've learned. So the Google Data Protocol. How many of you have written code against a Google Data or GData API? OK, a couple of you. So the couple of you will be familiar with this. Otherwise, I'll explain it for the rest of you. But basically, the Google Data Protocol was what our APIs have used for a number of years. When I first started at Google 5 years ago, I worked on the Google Data APIs team, first on Calendar API, and then we launched many other APIs based off of this protocol. And this protocol has adopted over the years, but it's become a fairly heavy stack. So let's look at what that stack looks like. It's basically HTTP or HTTPS for the transport layer, a variety of different authorization mechanisms for authorization. We have the proprietary ones like client login and auth-sub, which were Google developed authorization mechanisms before standards existed for such things. And then OAuth 1 and OAuth 2 as the standardized versions of these protocols. And Google Data APIs support all of these. Then on top of that, the Google Data Protocol is XML. How many of you like XML? There's actually a handful of you, more hands than I've seen in some other conferences. But the Google Data Protocol is based entirely on XML. And sitting on top of XML, we have the Atom syndication format, which looks awful like a blog feed. And then we have the Atom publishing protocol sitting on top of that. And all on top of this is the Google data specification. So we're specific protocol methods and specific data elements that are based off of the Google Data Protocol, and then a lot of other stuff based off these other specifications. And there's even some specifications, say like OpenSearch and all, that I didn't even name in this slide. But basically, it's a fairly heavyweight protocol stack for the Google Data APIs. And if you look at what this looks like over the wire, this is retrieving a list of calendar events. Okay, and it's very small. I realize this. You probably can't read it. But I can say one thing, that there's not even a calendar event yet on this. This is all metadata describing the feed. And this happens every time you do an API request to get a list of calendar events. As we move more towards lower latency environments and mobile applications in particular, having all this extra cruft can be kind of frustrating for some developers. So the Google Data Protocol also has some feature inconsistency. Calendar, for instance, supports this thing called partial get and partial retrieval, partial get and partial updates, which allows you to get just certain elements of data and update just certain elements of data instead of entire REST entity. Google Docs supports a batch protocol, and other APIs support different protocols as part of these Google Data API sets. And the reason for this is basically every team rolls out their own sort of implementation of the Google Data APIs. We provide some central library at Google, but all the teams adopt that library and then roll out their own implementation, and sometimes they add features to it. So as you work with the different APIs, you may have a different set of features going across them. Now, we want to basically make this easier. So there's a number of challenges for developers. This first one is big. It requires this knowledge, expertise, and adjunct specifications. You notice a lot of our GData APIs kind of point back to the core GData documentation, and that the core GData documentation points back to the Atom Publishing Protocol specification and the Atom specification. There's a lot of kind of extra stuff in here that a lot of developers don't necessarily want to have to reference. So it requires a lot of knowledge and expertise. There's verbose data, as you saw. XML is not easy on some platforms. We particularly found this early on with PHP, dealing with like namespaces in PHP with XML tended to be rather difficult. And other languages are just the same. And JavaScript and XML isn't always great. And so we found developers over and over again asking for JSON as an output format, as a more simple output format. And because XML is used by the Google Data APIs, we basically designed this client library strategy such that every XML element became a separate class. So if you looked at the PHP library or the Java library or the .NET libraries, every single XML element was represented by another class. And having that makes the libraries very hard to maintain. So the libraries can get a little out of date, which means that you guys don't get to actually use the most modern features of the APIs if you are using one of the libraries. You kind of have to hard code it yourself or hand code it yourself if you want to use the most recent versions of the libraries. And this is all a challenge. And then, of course, the inconsistent feature sets that we talked about. So we like to iterate. We like to learn from this stuff. And we like to produce new APIs that are better and take your feedback into account. So what we've designed is this new API stack. And some APIs, I'll give you some examples, have already launched with this. But we've just recently started using this for Google Apps APIs in particular. This API stack is based off of HTTPS and just the OAuth methods of authorization. Now, there's a variety of different data formats. The big key difference here is with these APIs and this new stack is that the data formats are read-write. In the Google Data Protocol, we had read-write Atom, but every other output format we produced was only read-only. So we did produce a JSON format that was really ugly, looked a lot like XML, but it was only read-only. With the new stack, you can have read-write protocols across these variety of APIs. But in reality, you really just need to do with this stack. Very simple. You just need to deal with JSON, you just need to deal with OAuth 2, and you just need to deal with HTTPS. That's it. Quite simple for you as developers, and that's how we like it, because it's easier to document, easier to support, and obviously you guys are happier with this. So how many of you, there was a few people that really liked XML. How many people would rather have JSON than XML? All right, good. We made the right choice then, at least for this audience. So JSON is the default format for all of those APIs on this new stack. But like I said, there are other output formats in some cases where you do want to get Atom or you do want to get XML. Some of the APIs support that. But we do have improved consistency across the feature set, the protocol feature set. Because we're using sort of a central infrastructure to host all these new APIs, as soon as we roll out a new feature like partial update and partial get, these features are immediately available across all the different APIs. And the APIs that are available, there's a number of APIs that aren't Google Apps APIs that you've probably seen use something similar to this, the Google Plus API, the Prediction API, URL shortener. But we've just started to roll this out for Google Apps APIs, and we plan to keep on rolling this out. So in Google Apps, we announced the Tasks API back at Google I/O. And the Tasks API is based off of this format. And then we also recently, I think it was Thursday, your time, launched the Group Settings API. And Calendar, a new version of the Calendar API, Calendar v3, is coming soon, which will support this new API stack and be easier to work with. So others will happen eventually, and we'll keep on rolling out our APIs in this new format. But we believe it's a lot easier for you to use this stack than the previous Google Data API stack. So I just want to give you some examples of the data format here. Again, JSON, pretty easy to read, easy to comprehend. You don't have to deal with namespaces in particular. And then partial response. Partial response is basically the ability for you to get just particular elements of data that you want to get. So if you're building a mobile client that interacts with the Google Tasks API, and you want to get just the title of each task as well as the ID of the task, you can get just that bit of data instead of getting the entire task entry. So if you think about this in something more verbose like calendar, you get just the title of a calendar entry or calendar event and not the entire, all the metadata about when it's taking place, where it's taking place, the description, the attendees, all that. This is very helpful, again, on the mobile sort of environment, and you can see how this looks here. It's very simple. So you see the GET request, and basically you're passing the fields into the GET request. You're basically saying, underneath items, I want the ID and the title. And that's all it is. And you'll get a return JSON object that looks something like this, where you basically have each of the tasks, the IDs, the title, and this will just keep on going on in an array. So very helpful to get partial responses. And one thing that we noticed over time with people that are implementing clients with Google Data is Google Data required this sort of, for most of the APIs, required this sort of very strict REST-like architecture. So what I mean by that is in order to update a calendar event, for instance, you had to retrieve the entire event. And if you just wanted to update one character in the title, after you retrieve the entire event, you need to update that one character and put the entire event back. It's basically what REST is all about, state transfer on an object or an entity. Well, we now allow partial update in addition to partial response with all these new APIs. Partial update uses the HTTP patch method, and the HTTP patch method allows you to just basically send the particular element of data that you're trying to update. So if we wanted to update just the title of a task, we can update just the title of a task. What this means is that unlimited bandwidth things like mobile devices, you don't actually have to retrieve that entire object, update the title, and put the entire object back. And you also don't have to store the entire object on the device. Both strategies were used oftentimes by developers. In this case, if someone updates the title of the task, you just send the new title. Very simple. Now, there's also RPC services supported by the new architecture of APIs. And RPC services came in very handy for certain types of operations. So actually, this is a little messed up slide here. But basically, think of RPC services as being useful for things like rotating a picture. You can't really represent a rotated picture in a REST model without downloading the whole picture, rotating it yourself, and putting the picture back up. It's much more handy to be able to basically send a RPC request and say, rotate this picture. And the new API infrastructure does support RPC methods in addition to the REST endpoints. So things like the rotate picture, or things like move a calendar event from one calendar to another, or things like that can be supported by this architecture. Now, I talked about client libraries, and I talked how it's difficult for us to maintain client libraries. And it was difficult because we had these new XML elements, new objects in classes for every XML element. What we're doing with this new API stack is using discovery. We basically have an API out there that allows you to retrieve and get all the information about a REST API, or any of our REST APIs. And it will tell you what is the format of the data in the APIs. It'll tell you what are the different query parameter options, what are the different RPC methods that you can use. It's basically a discovery format for APIs, and it returns this all as a JSON object. This allows us to create these sort of generic client libraries, and maybe better called dynamic. Generic kind of has a negative connotation at times. But basically, these client libraries actually go out and discover these resources from the discovery API and build themselves automatically based off of that. So for strongly typed languages, this can happen after you download the library, we can build the classes for the client libraries then. Or for weakly typed languages, so your PHP or Python or your scripting languages, we can actually basically put all the elements returned from the API and put them into native object arrays and that sort of thing. So here you can see actually some examples of that. So the generated classes for .NET or Java or strongly typed language, we basically just generate a class that represents a task in this case, and we iterate through those tasks and print them out. Or for other languages like PHP, scripting languages, we basically just have it in a named array, and so we can loop through the tasks as an array.
Do you mean that when I download a new version, you generate the classes from scratch, or do you mean that I, as a programmer, can access this Discovery API and start doing things like reflection?
Both. I mean, you can access the Discovery API, or our client libraries, as part of their build process, do access the Discovery API for generating the classes. We want you to still be able to use your IDEs and all to do autocomplete and all. That's why we can generate classes. But if you want to access the Discovery API, you're welcome to do that and build your own client libraries or do whatever you want with that Discovery service. So there is the APIs Explorer, which actually takes advantage of the Discovery service. And I can actually even show you to expand on that previous question here. The Discovery API is just another one of these APIs. So Discovery, let's see here. Well, we can read this. But V1 here of Discovery, we can retrieve a list of all the various APIs. And oops. Okay, somehow I'm not being able to drag this. All right, well, if you can look down here, basically, the response of the APIs basically gives you a list of all the different APIs. So I can zoom in a little bit. But this, for instance, is the AdSense API, and you can see it, the information about that. And then it links off to the basic name and the image and all, but you can get the further details about it by drilling down on it. The API Explorer is basically a tool which uses the Discovery service to list out each of our APIs and allows you to explore the APIs and actually just run them in a browser really easily. So if we say tasks, we can get basically a specific task list. I think we can say default here. I need to switch to private access and get my task list. Actually, it's not default here. Let me just return all my task lists here. For some reason, I'm not able to drag this bar here, but we can see down here I'm returning my task list, and basically the API Explorer allows us to really explore what the JSON looks like for each of these APIs, including that Discovery service. The new APIs also have this APIs console. The APIs console basically provides a central kind of control panel for accessing all your APIs. You can register for the APIs. You can get an OAuth client ID and client secret. And you can even see the traffic that you're generating to the APIs, see what URLs you're calling the most and which URLs are causing errors. Very helpful service for all the new different APIs. So let's just give you a couple examples about these next generation APIs and what it looks like for Google Tasks. How many of you use Google Tasks? OK. I keep on meaning to use Google Tasks. I don't use it often enough. But basically allows you to keep track of your tasks list. It's in Gmail, usually in the bottom right of your browser in Gmail. Looks something like this. And basically, this is our first of the new style APIs. As I said, it was launched in May. It exposes most of the functionality of the task manager in Gmail. The model looks something like this. We have the list of tasks, and then we can go down and look at the details of a task. You can rearrange their positioning, and there's a parent-child relationship as well. All very simple JSON. And that's what the URL structure looks like. And then, so that was just a quick preview on tasks, but Groups API is one that we actually just launched this week. So for those of you who use Google Apps, Google Groups is pretty powerful. So we use Google Groups a lot internally, both for internal communication as well as for communicating with people outside Google. When I run trusted tester programs and that sort of thing, we create a Google Group to manage the trusted tester program. So Google Groups can be used for email distribution lists, but it can also be used for access control lists. So you think about something like Google Storage. You can actually share an object in Google Storage to a particular Google group. The same thing is true in Google Docs. When you have a Google document or a collection of Google documents, you can share it with a Google group. All of this is great. But right now, or prior to this API launch, these groups could only be created and managed in the UI. When you created a group, you could manage all the settings. Sorry, you could create the groups with the provisioning API before, but managing the settings you had to do using the UI. So you oftentimes were kind of comparing two groups in two different browsers and copying and pasting the settings if you knew you wanted to recreate a group that had the same sort of settings as a previous one that you had. Like I said, we use this a lot in trusted tester programs. So with a trusted tester mailing list, we like to open up the mailing list to people outside Google. But since oftentimes the trusted testers don't know who each other is and that sort of thing, we don't want each of them seeing each other's messages and email addresses and all like that. There's a lot of different settings that you have to configure in Google Groups to accomplish all of this. And you couldn't do it in any sort of automated fashion before this API launched this week. So the Group Settings API basically is the first of the new style APIs in the management type. And the Group Settings API allows you to do two very simple operations. Get a list of the group settings and set the group settings. It's all done in JSON. You can still do the partial get and partial update for this as well. And it looks something like this. And let me just zoom in here. I'm not going to be able to actually zoom in on the slides here. But to start with, at the top, we're basically saying get the settings for the group called salesgroup@example.com. And it returns basically this JSON object of all the settings. And there's a lot of different settings there, everything from the fonts to the permissions of who can send and receive email to what happens when a message is denied, what message gets returned to the person who sent the message that was denied, and things like that. A lot of different settings that you can manage using this new API. And it was very easy for the team that built this group settings API to launch this API because it was based off of this new infrastructure. So we talked about the new infrastructure. We talked about how we're moving away from the Google Data APIs to this new style of APIs based off of JSON, which apparently the audience here really likes JSON a lot more than the old style XML, which is great. And it makes it faster for us to launch APIs. It also makes it easier for us to maintain APIs. And these are all the data APIs that you guys use, the REST APIs or RPC APIs. We also have these things called AppScript. And AppScript is the JavaScript engine that runs in the cloud. How many of you have actually used AppScript? Just a handful of you. Well, my next session is all about AppScript, so I don't go into too much detail here. But AppScript basically allows you to run JavaScript on Google servers in the cloud to automate tasks across Gmail, Calendar, Docs, Finance, Translate, a lot of different Google services. And one of the things that AppScript recently released is the ability to call these various new style APIs that I was just talking about. AppScript actually uses the discovery service, just like any of our other client libraries do, to basically allow you to call these new APIs from within AppScript. And so you can configure all of this using the AppScript online IDE. In this case, so far we've supported BigQuery prediction tasks and the URL shortener API, but as more APIs get released, we can support more of those within AppScript. So AppScript has had huge momentum in launching a lot of things. All of this stuff has launched since Google I/O, some in the last couple weeks. We launched caching with Memcache. We launched locking to prevent two scripts that are simultaneously modifying a spreadsheet or a document from colliding with each other. We launched a UI builder that allows you to kind of drag and drop and build UIs to automate sort of workflow experiences for your users. Charts, a Gmail interface to allow you to send and read emails. Google Docs allows you to create documents, editing paragraph by paragraph and things like that. Here's some examples of some of this functionality, the UI builder. Chart functionality. Gmail has the same standard-based API that you're looking at. You can get messages, you can get labels, you can send messages. And Google Docs allows you to, like I said, retrieve and update documents, append paragraphs, basically dynamically work with Google Docs in a scripting language. Without, like, the doclist API that's available by GData right now requires you to essentially update the whole document at a time. This AppScript interface allows you to do this paragraph by paragraph work. So, like I said, I'm giving the next talk on AppScript, so I didn't want to go into too much detail there. But one of the last things I want to talk about here is the Picker API. So we recognize that developers are often doing repetitive things. Developers are building the same types of integrations with Google Apps over and over again because a lot of different types of applications require the same types of integrations. This is true of a Google Docs picker. So this is an example from the ManyMoon project management application of how they allow you to pick a Google document from your Google Docs list and attach it to a project in the project management system. So basically, they list out all the different docs that are in your Google Docs, and they allow you to select one and attach it to the project. Well, many developers are building this exact same sort of interface. And instead of concentrating on the things that they do best, on their specialties, on their true business application, they're just building this doc list picker over and over again. So we decided to make it easier and launch the Picker API, which does a very similar thing. Basically, it is a simple JavaScript library that allows you to get a list of the user's Google Docs, and the user picks a Google Doc, and it returns the Google Doc that they've picked back to your application. So you don't actually have to build all the JavaScript and CSS and HTML for this Picker UI. We do it for you. Pop open to a demo here to show you what that looks like. And some of this stuff is HTTP, so let's switch over here. So select a document. So imagine a project management app or a CRM app or any other type of app that wants to have Google Docs be integrated with it. It can just basically run very simple JavaScript, and then we can say select a document. And let's see. I don't know if I've tried this with a presentation yet, but let's do it. So I'm going to choose a presentation. And you notice one thing here. It says, how would you, or what would you like to share this item? And I can choose to grant access to this item to the application. So this whole UI is being rendered by Google. The developer here just did a very simple JavaScript function call, and I'm going to choose to grant access to it. And what happens here is the picker returns back to the application this JSON object. And this JSON object has all sorts of information about the document that I just chose. It has the ID of the doc. It says it's a presentation. It has the MIME type, last edited date, the URL, even some thumbnail images. So we can use that. We can generate these thumbnail images. We can generate a preview window that shows this presentation. And we also, because I was able to grant access to that doc, it basically gave an OAuth 2 token to the application that allows it then to use the Google Data API to work with this document more. It allows it to edit the document and things like that over a span of 24 hours. So it gives the application access to that doc for a short period of time to allow it to include it within the project management app as an example here. Here's some quick JavaScript. Basically, we're loading the picker, we're creating the picker, and we're basically specifying here that we want to do the picker to pick Google Docs. The picker also supports things like YouTube videos or Picasa or things like that as well. But in this case, we're worried about Google Docs. So we tell it we want a picker for Google Docs, we want to make it visible, and then after I pick something, it calls this callback function here called picker callback and passes in that JSON object with all the data about the doc. Quite simple, and basically allows a developer to concentrate on the business logic that's most important to their application while we deal with a repetitive sort of interface like a doc picker. And like I said, it returns this OAuth2 access token, which you can then use to retrieve more information about the doc, edit the doc, et cetera. The picker does support localization. You can choose what language you want the picker to be displayed in when you pass in the Google.load method. Auth, we keep on moving on with authorization and adopting the latest standards and working with the standards community around authorization. For those of you who saw my most recent talk earlier today, I talked a lot about OAuth2 and OpenID Connect. In terms of the Google Apps API side of things, we already support OAuth2. OpenID Connect support is, and OAuth2 support are in experimental stages. We definitely encourage you all to check it out. And we also recently launched this OAuth2 Playground to make it a lot easier for you to use OAuth2 and play around with it with your APIs. So this guides you through the whole process of OAuth2, gives you an access token, allows you to play around with the new Google Apps APIs, or even the old Google Data APIs as well. So on the distribution side, how many of you are familiar with the Google Apps Marketplace? How many of you have seen it? All right. How many of you have an application in the Apps Marketplace? Okay, the same people that have seen it have the application in it. I'm not sure if this is a good sign. But the Google Apps Marketplace is basically a web application store for business applications for all the Google Apps customers. They can go here as IT administrators and buy applications. And we'd encourage you, if you build these applications which integrate with Google Apps and you want to sell them, that you look at the Google Apps Marketplace as a distribution channel. We've also been doing some things recently. If we talk about new APIs and features, we've added some things to the Apps Marketplace. Single sign-on has always been there, and that's kind of the core requirement, as well as integrating with a lot of APIs. But the things that we've added, installed apps for individual users. We just have a kind of a small beta test for this right now, but basically the Apps Marketplace started off with having installed apps being done by administrators. So administrators would install the applications for their entire domain. We now have, in this beta test of sorts, the ability for individual users to come and purchase these applications from the Apps Marketplace. And they get that single sign-on experience. They get a navigation element in their universal navigation bar, and the applications get data access and that sort of thing. We also recently launched Staff's Picks on the home page. Basically, we're really trying to encourage you guys to do really deep and innovative integrations with Google Apps. And when you do that, we want to feature you. We want to drive you business. So we launched Staff Picks feature on the home page to feature some of the deeply integrated applications on the marketplace itself. These aren't always the most popular and well-known applications, but they are applications that integrate well with Google Apps in sometimes very innovative ways. Improve searching and analytics to make it easier for you to market your application. So overall, we believe in this 100% web for business mission. We believe that every business should be running their business entirely on the web. They should have the applications that they need to do that, whether it be the applications that Google produces as part of the Google Apps Suite, or whether it be the applications that you guys build and sell to the Google Apps customer base, or the customs integrations that you guys build, all this on top of the Google Apps APIs. Lots of different tools available. You have the data APIs that are moving from the Google data format to this new API infrastructure, as well as AppScript, which is this JavaScript engine in the cloud. And you have this easy integrations that we're trying to basically eliminate a lot of the duplicate work that developers are doing across our various APIs. And then, of course, you have these distribution opportunities via the Apps Marketplace. And that's it. We have some resources up here, and I'm also happy to take any questions. Thank you very much.